So our lesson today is about angles. We're talking about measuring them and classifying them. We've talked about this a little bit already. So the first thing I want to talk about is, did you remember that sort of the corner of the angle is called the vertex? And then those two rays that come off of there, we call those the sides of the angle. But really the angle is the opening that is made. Remember, we have 4 ways to name this angle. I wonder if you can come up with all 4. One of them is just to name it using the vertex. We could call that angle A. Another way, we could call it angle CAB. We could call it BAC. Don't be afraid to talk out loud to me right now. Can you tell me, is there anything special about the order of those letters? Say it out loud. The vertex has to be in the middle. And so what's the one way that we're missing now? We've got the A, the vertex in the middle. The other way was sometimes we just number the angles. So let's say we wanted to put a little 4 in that opening. That doesn't mean 4 degrees. It just means that we're going to refer to that as angle 4. And then if we measure that angle, the tool that we use to measure an angle is a protractor. And we put a little m in front to say that, hey, we're about to talk about degrees. And so I'll grab a protractor, I'll measure that angle, and let's say the measure of angle A comes out to be 37 degrees. I would say the measure of angle A equals 37 degrees. So that's how you would write it once you actually have a measurement. Classifying angles. What types of angles do you know of? We know that there's right angles. Start shouting out, what other types of angles do you know? Right. Acute. Obtuse. Did you come up with the last one? Straight. I'm just going to draw a little picture of each of those. So a right angle has a vertex, and those rays make a, remember the 90-degree angle box? So then we could say, if that was angle A, we could say the measure of angle A equals 90 degrees. For an acute angle, maybe something like this. What would you say about the measure of angle A there? Well, you would say that it's less than 90, but we should also probably technically say that it's more than 0. Because once you get into like JV math, then you'll talk about negative angles and stuff. Let's talk about obtuse angles. There's an obtuse angle. What would you say about the measure of that angle? You would say that it's bigger than 90, but does it have to be smaller than anything? So it would be somewhere between 90 and 180. So we would say the angle is less than 180, but bigger than 90. That's how you would write that inequality. And then finally, a straight angle. Some people don't think this looks like an angle at all, but picture this. You've got a ray, and then picture that door opening all the way open. So it's just that the two sides of the angle are opposite rays. And what could we say about the measure of that angle? Even though it just looks like it's a straight line, it's still an angle. You could measure it with a protractor. And the measure of angle A would equal 180 degrees. Technical difficulties, just a second. Woohoo. Lovely. We did this yesterday. We talked about using a protractor, making sure that the point, the vertex point, was at the center, And then you can twist your little guy around until you get one of the zeros to line up with one of the edges you need, right? So we talked about that. One thing I just wanted to mention is that there's a really good reason that I didn't ask on any of these why, like, to find the measure of angle F. Because if I just called this angle F, you would have no idea which of the angle F's I was talking about. By the way, help each other use the protractor if anybody's having trouble today. All right, two more things, and these are both going to be related to segment things we learned. We learned about the segment addition postulate. Remember what that said? Segment addition was where a little segment length plus a little segment length equals a big segment length. That's the segment addition postulate. The angle addition postulate is the same idea. If you have, oh dear, troubles. All right, so segment addition, two smaller segments add up to equal the length of the longer one. For angle addition, we'd have two smaller angles that add up to equal the measure of the big angle, right? And so the way that they say the angle addition postulate, it sounds super confusing, but all it's saying is that the two smaller angles added together equals the measure of the big angle. I think if I were going to write a geometry book, I would probably draw a picture more like this. I might put an A here, a B here, and a C here, and I might just call this angle 1 and this angle 2. And for my angle addition postulate, I just might say the measure of angle 1 plus the measure of angle 2 equals the measure of angle, I don't want to just call it angle B because there's lots of, so how about ABC? The two smaller measures add up to the big measure. Angle addition postulate. One other thing that's a little similar to a segment thing we learned is an angle bisector. An angle bisector is going to cut your angle in half. But not just in half, like in half. Into two congruent pieces. So if you take, I'm going to draw my own picture over here. If I had like some obtuse angle, if I wanted to bisect that angle, I wouldn't want to cut it here. No, that wouldn't work. That's not considered a bisector because I didn't split it into two congruent pieces. So in order to bisect, it has to be two congruent pieces. My pen is just hating me, I'm sorry. Oh, remember when we had segment bisectors and we had midpoints? And remember how as soon as you draw a midpoint, you like to make a tick-tick? What do you do when you have an angle bisector? Do you tick those two angles? The answer is we don't tick them, we swoop them. And so we would say that this angle is congruent to this angle. And I just offset them a little bit so it doesn't look like I made one big swoop. Or since single swoops are already used on this picture, maybe I would do a double swoop, kind of like a double tick. And that just means that those two are congruent. So if this were a 55-degree angle, then this would be a 55-degree angle because I see those double swoops on there, right? So yeah, angle bisector, here's a little problem we're going to try to solve. It says that the measure of angle XYW, XYW, that must be this top one, is 18 degrees. And it says that this is an angle bisector. So swoop, swoop, those two are equal. Be careful when you answer the question though, because they're asking for the measure of angle X, Y, Z. And so when you look at the picture, do you see where the X, Y, Z is? X, Y, Z is actually the whole thing, right? X to Y to Z. So since that's 18, this one's 18. Really? And so the total is going to be, what would that be? 36, true? So then we would say the measure of angle XYZ equals 36. 36 degrees. Beautiful. So that's basically what we were supposed to learn today. Your assignment's written on the backboard for you. We're going to start on page 28 for this assignment. The protractors are over in the bin by the door. Good luck, and I will see you Thursday.